This video tutorial I will explain Apache Kafka workflow. Kafka is nothing but collection of topics where each topic is split into one or more partitions. Here you can see the topic. It has three partitions: partition 0, partition 1 and partition 2. And each partition contains sequence of messages, and each message is identified by their index, and index is also called offset. And all the data in Kafka cluster is disjoint union of all the partitions, and incoming messages are written at the end of the partition, and messages are sequentially read by consumers. And Kafka support durability, and durability is provided by replicating messages to different brokers. Kafka provides both publish subscribe and queue based messaging system in a fast, reliable, persisted, fault tolerance and zero downtime manner. In both cases, producers simply send messages to the topic, and the consumer can choose any one type of messaging system depending on their need. Now we will see workflow of publish subscribe messaging. Here you can see the Kafka cluster. It has four brokers, and here you can see the producers which send message to the topic at regular intervals. And Kafka broker store all the messages in the partition which is configured for the particular topic. And Kafka ensures messages are equally shared between the partitions. If the producer send two messages and there are two partitions, in this case Kafka will store one message in the first partition and second message in the second partition. Here you can see the consumer group. It has three consumers. Consumer subscribes to the specific topic. Once consumer subscribes to the topic, Kafka will provide current offset of the topic to the consumer and also saves the offset to the Zookeeper. And the consumer will request the Kafka in a regular interval for new messages. And once Kafka receives the messages from producers, Kafka forward these messages to the consumers. Consumer will receive the message and process it. Once messages are processed, consumer will send an acknowledgement to the Kafka broker. Once Kafka receives an acknowledgement, it changes the offset to the new value, and new value will be updated to Zookeeper. Since offsets are maintained in the Zookeeper, the consumer can read next message correctly even during server outages, and this flow will repeat until consumer stops the request. And the consumer has option to rewind or skip to the desired offset of the topic at any time and read all the subsequent messages. Now we will see the workflow of Kafka queue messaging or consumer group. Here you can see the producers which send a message to the topic in a regular interval, and Kafka stores all the messages in the partition which is configured for the particular topic, similar to the earlier scenario. Here you can see the consumer group, and assume initially only one consumer is there, and that consumer subscribes to the topic. In this scenario, Kafka interacts with the consumer in the same way as publish subscribe messaging until the new consumer subscribes to the topic, and the new consumer which belongs to the same consumer group. Once the new consumer arrives in the same consumer group and which subscribes to same topic, then Kafka switches its operation to a share mode and shares the data between two consumers. This sharing will go until the number of consumers reach the number of partition configured for the particular topic. And once number of consumer exceeds number of partition, then the new consumer will not receive any further message until one of the existing consumer unsubscribes. This scenario arises because each consumer in the Kafka will be assigned to minimum of one partition. Once all the partitions are assigned to the existing consumers, the new consumers will have to wait. This feature is also called consumer group. Here you can see the Zookeeper. Now we will see the role of Zookeeper in Apache Kafka. A critical dependency of Apache Kafka is Apache Zookeeper. Apache Zookeeper is a distributed configuration and synchronization service. Zookeeper acts as a coordination interface between Kafka brokers and consumers. Kafka servers share information via Zookeeper cluster. Kafka stores basic metadata in Zookeeper, such as information about topics, brokers, consumer offsets, and so on. Since all the critical information is stored in Zookeeper and it normally replicates the data across its ensemble, and failure of Kafka broker or Zookeeper does not affect the state of the Kafka cluster. Kafka will restore the state once Zookeeper restarts. This gives zero downtime for Kafka. And the leader election between Kafka broker is also done by using Zookeeper in the event of leader failure.
You can get the Java source code link from the description section of the video. To see the description in mobile, click on this icon and it will expand like this. Then click on this more button to see the description. And in the description, you can see the links. And click on these links to get the Java source code.